morning, everyone. It seems a little bit, I don't know, sacrilegious or something, doesn't it, to be sitting inside here on this glorious day, sunny day, talking about the dark side of the universe. But it's going to be worth it, I'm absolutely sure. I often feel that one of the best rejoinders to the suggestion you sometimes hear that scientists like to think they know everything and can explain everything is the response that came from the discovery in the late 1990s that the universe seems to be expanding at an accelerating rate, which was one of the key motivating factors behind this idea of dark energy. Because, you know, that discovery showed how profoundly it seemed we'd missed something about the makeup of the cosmos. Something that now seems to tell us that around 70% of the energy in the observable universe comes from this stuff called dark energy. And, you know, another 20-25% of it comes from this other stuff called dark matter, which we don't have time to talk about today. Just to make things clear, dark matter and dark energy are different things, if you weren't already clear about that, and we're talking about the former. And so what is this stuff, this energy that seems to be there, apparently, but that we hadn't previously noticed? So that's what we're here to talk about, and to do that we have certainly two experts from different perspectives on this subject. Erik Vellinder, on my right, is a professor of theoretical physics at the University of Amsterdam. Michael Duff, on my left, is also a theoretical physicist and a string theorist from Imperial College in London. And as you've just heard, Massimo Pugliaccio has very generously agreed to sit in the third chair that otherwise would have been vacant for this discussion. And Massimo, I guess you'll offer us a very different take, an outsider's take, I suppose, on this
the comic relief
question.
Right. Yes.
Oh, great, lovely. That's always a good thing. So first of all, I'll give you Erik Vellinder to talk about his take on dark energy.
Yes, I mean, dark energy is mysterious, but it's certainly there, and I think it's there for a reason. The universe is extremely large. It's also very dark. I mean, not totally dark. It's also not infinitely large. And it's also not infinitely empty. Indeed, there's something there. I mean, if we look at the observed accelerated expansion of the universe, it indicates that space is filled with something, and that's the dark energy that we're discussing. I will explain the relationship between dark energy and the expansion a little later. So I truly believe, by the way, it exists. It's not something that's not there, but it's not described in the correct way. Our current theory, which is based on general relativity, is namely incomplete. That's my main point I want to make. In Einstein's gravity, we think about space-time basically as having no properties. It's like a stage on which matter moves under the influence of forces. But I think there are reasons, both from the observations as well from theory, to really challenge that point of view, that space-time is empty or made of nothing. First of all, there is indeed the fact that 95% of the energy budget is in these mysterious forms, which is either dark matter or dark energy. But also we have insights from string theory, from black hole physics, that tell us that space-time and gravity eventually will emerge. I mean, it comes about from something microscopic in which these phenomena have no real meaning. So dark energy and dark matter constitute this 95% of the energy budget. I mean, the stars that we see is less than 1%. And if we look at our current laws of physics, we only describe what's being observed. And what we observed are the stars and maybe the radiation from the Big Bang, but that's only a very tiny fraction of all of the energy in our universe. Now, in physics, we generally ignore